Oh, good evening. My name is Folorunso Olusake, and this is my second reflection on my favorite problem. And I would like to extend the Sierpinski triangle problem to square to know the areas and general trend if one quarter of square size is cut out or cut off or removed continuously. I mean, from as they are going, it is being removing. Though I have so many favorite problems in this course, but in my curiosity, I dug deep to extend the principle of scientific triangle to a square. Here we go. Scenario or method. So as I was saying earlier, the first thing that we need to do here is for us to draw a square, and we call that square A naught. And the area of that triangle, the area of that square is also called A naught, that is written in this place. Now, the A1, which is also square A1, and the area of that square is called A1. As we could see from this place, it has been divided into 4 equal parts, and that is a bisect. So, the EC squared, the area of EC squared is 1 over 4 A naught. That is, the first one is being cut out of the triangle. So we are now left with A, B, and C. We are now left with A, B, and C. So A1, the area of A1 is A1A plus A1B plus A1C. We give us to 1 over 4 A naught plus 1 over 4 A naught plus 1 over 4 A naught. As I explained earlier that the cut out, the area is 1 over 4 A. So A, B, C, they also have an area of 1 over 4 A naught. So having had all of them together, it will give us 3 over 4 A naught, which is different previously from my reflections from my favorite problem 1. So A2, we move down to A2, which is further bisecting of the square to a smaller unit or smaller portion of squared. Now you could see from this place, from A, B, C. So I just assume that the previous A1, I will continue with that. So if you will now divide the A into 4, B into 4, and C into 4, and we cut off one of the unit. So we are now removing 3 units, 1, 2, 3, from this from this squared. So the A1, the A21, the A21 will now be A21 is equal to 3 over 4 multiplied by 1 over 4 A naught. Why we are using 3 over 4 is because it is now left with 1, 2, 3 portion of the A. So we now have 3 over 4 multiplied by 1 over 4 A naught give us 3 over 16 A naught. The same thing applicable to A2B and A2C. So we now, why I'm doing it this way is for basic understanding of what we are discussing here, and especially when I'm teaching my future students, for them to really know why things are happening or why things is being expressed as this, because the basic understanding of a thing is very, very important, like what our instructor did in this course. Now, the total areas will now be A2A plus A2B plus A2C, which we add all of them together, give us 9 over 16 A naught. So now that's one emphasis I need to lay in this place. The emphasis is this: when you look at this 9 here, because some students might just say, why do we have 9 over 16? But there are some sharp students, they will quickly go back to the to the A2 drawing, you can see that when you count the number of squared, when you count the number of unit square that are not shaded here, it's just 9. That is 1, 2, 3, 4, 5, 6, 7, 8. This is 9. It means all we need to do, since we know the area of each unit here, which is 1 over 16a, is for just us to multiply 9 multiplied by 1 over 16a naught, and we also arrive at 9 over 16a naught. That's another short way of thinking and doing mathematics. But sometimes it might not help, but better explanation will give some struggling students the better understanding of what we are doing in this place. Now, in my curiosity, I just okay, because my mind is that I was just thinking of general phenomenon, how this thing could be applied to any squared. And I'm still going to try for that rectangle, whether it's going to be work, whether it's going to work or not. But I believe it's going to work. But I will still give it a try. So let us extend to A3 of the trend, if the trend will continue. So apply the same principle from the previous example that I just gave from A2. You could easily see that I just counted the number of squared, which is 9. Which is 9. 9 multiplied by the number of the unit area, and give us the answer. This is the method I want to use in this place, not to go for the fragment. So from here, I know we have 27 squared here. We have 27 squared here. And why I'm using this method is for students to know that there's a variety of ways you can think and do mathematics. So we have 27 squared here. And the area of each square will be 1 over 64. And I just said, how? How did we arrive at that? How do we arrive at 1 over 64? And at this point, I can actually ask my student, okay, will anybody explain to me why we arrive at 64, 1 over 64 here? And I believe some students from the previous what I've said, they'll be able to show, so this is how we do it, this is how we do it, because we know that the previous one is just 1 over 4, and the second one is 1 over 4 multiplied by 1 over 4 is 1 over 16, and I believe this one will be 1 over 16 multiplied by 1 over 4. So, just by, so from there, which means each small unit is fraction of the main size, A naught. So we got A is 3 is equal to 27 over 64 times A naught. So finally, what the purpose of this thing, one of the purposes of this thing is for me to know if we can generate a general formula. Now, A naught is A naught. We have A naught, A1, A3, A2. You can see A naught is this. 3 over 4, A naught is equal to A1. A2 is equal to 9 over 16 A naught. And A3 is equal to 27 over 64 A naught. So 3 over 4 is a common factor in this place. So I say, therefore, A naught is equal to 3 over 4 raised to power 1 A naught. A2 is equal to 3 over 4 raised to power 2 A naught. A3 is equal to 3 over 4. A3 is equal to 3 over 4 raised to power 3 A naught. Now, why do we have 3 over 4? Now, let us look at this. This is 3 over 4, and 9 over 16 is the same thing as 3 multiplied by 3 over 4 multiplied by 4. And 27 is 3 multiplied by 3 multiplied by 3 over 64. 64 is also written as 4 multiplied by 4 multiplied by 4. So it will be 3 over 3 raised to power 3, 3 over 4 raised to power 2. Finally, I'm now trying to extend it to if A is 4, that is A4. It will be 3 over 4 raised to power 4 A naught. And if it is 5, it will be, these are the questions I'm going to ask my students anyway, just to know that they really follow what I am doing. So general formula should be like this at this point in time. I see it unwise on the part of mean if I just write an is equal to 3 over 4 is power is equal to a naught. Or some student might be wondering, how did he arrive at this one? I think it is expedient for me to group the student into group of 4 or 5 and ask them from this point of A1, A2, A3, can they write a general formula in a group? I just put them in the group of 4 and I ask them to present it on the board. And from there, at least I will have a different kind of ways of writing these things out. So, and finally, I will ask them, what is the common ratio? And finally, as I conclude, this method, we can also use T table to calculate it as well. Thank you for listening. Bye.